We're going to factor using the difference of two squares. So first off, we're going to multiply each of the binomials. What do you notice about the middle terms is what's most important about the first four examples. For example 1, I'm going to multiply x and x, and that's going to give me x squared. X times negative 8 gives me a negative 8x. 8 times x, which are my inner terms, gives me a positive 8x. 8 times negative 8 gives me a negative 64. Again, what do you notice about the middle terms? Yes, they're going to cancel. Your answer, x squared minus 64. For example 2, we're going to repeat the pattern. We're going to multiply these and we're going to use FOIL. 2x times 2x is 4x squared. 2x times negative 3 is a negative 6x. Our inner terms, 3 times 2x is a positive 6x. And 3 times negative 3 is a negative 9. My middle terms are going to cancel, and I am left with 4x squared minus 9. For example 3, 2x times 2x is 4x squared. 2x times negative 5 gives a negative 10x. Positive 5 times 2x gives a positive 10x. 5 times negative 5 is a negative 25. Final answer, 4x squared minus 25. Example 4, x plus 3 times x minus 3. Again, we're going to multiply the first terms. X and x is x squared. X times negative 3 is negative 3x. 3 times x is a positive 3x. And 3 times negative 3 is a negative 9. Those middle terms, they're going to cancel. And I'm left with x squared minus 9. For the next set of problems, we're going to factor them using the difference of squares. I want you to remember from the examples we just had, we multiplied the terms. One was positive and one was negative. So we're going to factor each of the following using the difference of squares. That word squares is coming from square roots. So we're looking at numbers that are perfect squares that we can take the square root of. So for example 5, I have 9x squared minus 25. Under my radical, I'm going to write 3x times 3x. And then under the second radical, I'm going to write 5 times 5. What's most important about this is I have two binomials. One of them will be positive, one will be negative. If you look at my first radical, 3x times 3x, I'm going to put a 3x here. I'm going to put a 3x there. So the 3x goes in the first position. In the factor terms, here in my parentheses, I'm going to write a 5 here, and I'm going to write a 5 there. My answer to example 5 is 3x plus 5, 3x minus 5. For example 6, I'm going to show you a different method. For example 6, I'm going to draw the x. In the top of the x, I am going to write negative 81 because of AC. And if you notice, there's not a b term, so b will simply be 0. I need two numbers to multiply to give me negative 81, but those same numbers are going to add to give me a 0. What would they be? Yes, 9 and negative 9. When I write my answer in factored form, it is x plus 9 times x minus 9. For example 7, I'm going to do the same thing I did for example 6. So I'm going to write my x. In the top, I'm going to write a negative 49. In the bottom, I'm going to write a 0 because I have A and C and I don't have a B term. Two numbers that multiply to give me negative 49 add to give me 0, positive 7, and a negative 7. When I write my answer, I have x plus 7, x minus 7. Please don't forget, one of your factor terms will be positive and the other one will be negative. So for example 8, I'm going to simplify the 25x squared into 5x times 5x. The 64 is 8 times 8. Again, these are your perfect squares. In my factor form or in my parentheses, I have a positive 1 and a negative 1. I put the 5x in the front of both terms, and I put the 8 in the second position of both. My final answer, for example 8, is 5x plus 8 times 5x minus 8.